Okay, gentlemen, welcome to 6.1 day 2 slope y-intercept form. Just to get the math juices flowing, let's take a look at a review from last lesson. You'll recall that we learned a little bit about cross multiplication, and we employed the use of cross reducing as well to help us eliminate the denominator. So we're going to do that here, and we're going to do that here. And the way we eliminate the denominator is by multiplying each term by the lowest common multiple, or what you know as the common denominator. In this case, 3 times 7 is the common denominator, which is 21. So we're going to multiply everything by 21. We're basically making everything 21 times bigger. Why are we doing that? So we can eliminate the denominator, because we know 3 will go evenly into 21, 7 will go evenly into 21, or you could say that 21 is divisible by 7 and 21 is divisible by 3 with no remainder. Now, if we want to cross reduce, we say 3 divided by 3 is 1, 21 divided by 3 is 7, 7 divided by 7 is 1, 21 divided by 7 is 3, and 21 times x is 21x. So we're left with 7x equal 3 plus 21x. Now we want to have our variables on the same side of the equation, so let's subtract 21x from both sides, and in essence bring it here. Equal 3, and now 7x minus 21 is negative 14x, equal 3, and we want to divide both sides by negative 14 so that we can isolate our variable x. In this case, x is going to equal negative 3 over 14. And you notice I put the negative in the middle because it doesn't matter whether the 3 or the 14 is negative, but regardless, the entire fraction is negative. Moving along to b, and you might want to pause the video and try this on your own here and see if you can get the same answer. But you want to multiply each term by the lowest common multiple, or the common denominator. And in this case, an easy strategy to find the common denominator is to look at the larger number, in this case, and look at multiples of 4. I know multiples of 3 are 3, 6, 9, etc., and 2 are 2, 4, 6, blah, 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 of course. But you want to use the larger number and see if it works with the others. So the multiples of 4, of course, are 4, 8, 12. Well, 8 doesn't work with 3, so that can't be it. But 12, you'll notice, soon does. 3, 6, 9, 12, and 2, 4, 6, 8, 10, 12. So dot, dot, dot there. And so 12 is going to be our lowest common multiple, or common denominator. So we're going to multiply everything here by 12. And the reason why I write it up high is because 12, as you know, is really 12 over 1. But instead of writing that every time, we just don't. I just write it a little higher up so we know it's a numerator, not a denominator. 4 divided by 4 is 1. 12 divided by 4 is 3. And then 12 divided by 3, of course, is 4. And 12 divided by 2 is 6. So we get 3 times x, which is 3x, equal 4 times 1, which is 4, plus 6 times x, which is 6x. And then we will, again, have our variables on the same side of the equation by subtracting 6x from both sides. And 3x minus 6x is negative 3x. And then we're going to divide both sides by negative 3, or the numerical coefficient, and we end up with x equal negative 4/3. And that's it. All right, another recap of last lesson is looking at horizontal lines and vertical lines. So you'll notice here there is a horizontal line running through 4. You'll notice in this question we have a vertical line running through 2, and then we'll deal with the middle one in a moment. I want to start with the first one, 2a. The slope is 0 because, like I mentioned in the last lesson, kind of like a roof. You can have a flat roof and there's no slope to it. The y-intercept is 4 because it runs through 4 on the y-axis. And technically, you may want to write y equals 0 slope times x plus 4, but we know that 0 times x is 0. So we eliminate that, and we simply write y equal 4. That's the equation of that line. For 2b, the slope can be calculated a number of ways. One way is to look at this point right here and this point right here. We want to see on the y-axis, where are we here? On the y-axis, we're at a positive 3, and the y-axis here is negative 3. So as you're reading, we want to read our graph left to right. As you read this line left to right, it's declining. It's going on a downward motion as you read it left to right. So we know the slope is going to be negative right off the bat. But the change in y value, so we know that slope is really rise over run, or the change in y over the change in x. In this case, we have little announcement. Sorry about that. So the rise is really negative 3 minus 3. It's the difference in the y values. And then we want to look at the difference in the x values. And you look here, we start, this first point actually runs through 0, and the second point on the x-axis actually runs through, so the first one is 0, and the second one runs through positive 3. So the difference there is 3 minus 0. So we end up with negative 3 minus 3, and you'll recall that when you are subtracting integers, you change subtraction to addition and change the following integer to its opposite. So we really have negative 3 plus negative 3, which is negative 6. And 3 minus 0, of course, is 3, and we can reduce that to negative 2. So we know our slope is negative 2. Another way of doing that, and you may find this way easier, so please, if that was too confusing for you, please follow along here. Another way of doing that is to look at this point right here, and we know that coordinate is 0, 3, and we know this coordinate right here, so I'm looking at these two coordinates here. This coordinate here is 3, negative 3. And we can use our formula slope equal y2 minus y1 over x2 minus x1. And in this case, I'll use this as my y2, subtract y1, and this will be x2 subtract x1. So the denominator is 3 minus 0, and the numerator we have negative 3 minus 3. And again, that's going to be negative 6 over 3, which is negative 2, and you'll get the same slope. Whatever strategy works for you is fair game. The y-intercept is easy because we see the y-intercept is at 3. That coordinate is 0, 3. So therefore, the y-intercept is 3, and our equation is y equal negative 2x plus 3. And the final line, to determine the equation of this, is a vertical line. We know it has rise, but there is no run to it. So we said this is another type of special case. The slope is actually undefined because if you remember, I was using the roof analogy. You can't technically have a building with, here's your, I think I did a drawing something like this where you had a window above, and you can't have a roof that's a vertical line. You could have a slanted roof. You could have a flat roof completely, but having a vertical roof makes no sense. That would be a wall. So one way we describe this, or one way of thinking about it, is like that. So the slope is undefined when it's vertical. The y-intercept, there is none, because it's running vertical and it will never pass through the y-axis. And in this case, the equation is x equal 2. And the reason why it's x equal 2 is because anywhere on this line, anywhere on this line whatsoever, the value of x will always be 2 because it's running through, you'll notice it's running through 2 on the x-axis. So here the x value is 2, here the x value is 2, here, here, and so forth, to infinity either direction. Okay, let's move on to some new material for today. Graphing equations. So we already learned that the equation of a line is y equal mx plus b. And we know m is slope, and we know that b is equal to the y-intercept, or where the line crosses the y-axis. In this case, we have a negative 4 for our y-intercept, so that's very easy to just plot that point. That's where it crosses the y-axis. The slope, on the other hand, is really 2 over 1. And we know slope is rise over run. Rise over run. So if the slope is 2 over 1, we know it rises 2 and runs 1. And they're both positive. So when the rise is positive, I'm going to go up 2, and the run is positive, I go right 1. And so that'll be another point right there. Up 2, right 1. Up 2, right 1. Up 2, right 1. And I can graph. That wasn't the greatest line. I can graph my line as such. I could probably do that a little bit straighter, but it is a straight line, and it runs through -4. The second question, or second equation, let's use a different color here. Actually, let's use the blue. We are going to start at the y-intercept, which is +3 in this case, and we know our slope is negative, so it's going to be going downward, reading it left to right. And I can attribute the -1. I can attribute the negative to the numerator or the denominator. So if the slope could be -1 over 4, or we could say the slope equal 1 over -4. And I'll explain why. So let's use the first example. The slope is -1 over 4. We're starting at 3 because that's our y-intercept, and we will go down 1 because it's -1, and right 4 because it's +4. So down 1 and 1, 2, 3, 4, and our next point will be here. Down 1 and 1, 2, 3, 4, right 4. Well, we can also start here at our original point, and we can say we go up 1, and here we can say we go left 4 because it's negative. So let's try that. Let's go up 1 and 1, 2, 3, 4, left 4, up 1, 1, 2, 3, 4, left 4. So we're along the same line. Let's try that one again as well. Not sure which one was better, but that we're basically going left to right. It's dropping, or it's going downward, so it's negative slope. And whether you choose to give the negative to the numerator or denominator just defines whether you're creating more line left or right. Okay, and here's our last question. The distance time graph is a person walking in front of a motion sensor. We know the y-intercept is obvious. It's right there. It's +1. So in the equation y equal mx plus b, I already know I have y equal mx plus 1. That's given. How far from the sensor did the person begin walking? We just answered that question. They begin 1 meter away from the sensor. Okay, because that would be 0 here. How fast did the person walk? Well, slope, in this case, we have distance, or the y-axis is distance, and the x-axis is time in seconds. Distance divided by time is speed. So you'll recall in distance time graphs, the slope is the speed. So let's calculate the slope. We already know the point 0, 1 is 1 point on our graph. And let me look for another coordinate. I can look at this coordinate right here, 4, 3. Looks like a reasonable coordinate. It's crossing through the grid points. And I will use my slope formula. Slope equal y2 minus y1 over x2 minus x1. And we have 3 minus 1 over 4 minus 0, which is 4. And we end up with 2 over 4, which of course is equal to 1/2. So the person is walking half a meter per second, or 0.5 meters per second. And by looking at the graph, you can tell if I go over to 1 second, up a half, over 1 second, up a half, over a second, up a half. Did the person walk away from or toward the sensor? Well, we can tell clearly the person is walking away from the sensor. As we read the graph left to right, the distance is increasing. So an explanation there would be as time increases, so does the distance, right? So for C, as time, there's my short form, increases, distance increases. So as they walk or as time passes, they are getting further away. Okay, that's today's lesson, and we'll see you tomorrow in class for textbook work.